2.7 Parent functions and transformations. So this is a huge lesson. This lesson is all about how to understand basic graphs. All these basic ones you should already know, and then move them up, down, left, right, stretch them, shrink them, flip them, rotate them. This lesson we're going to go back to every single chapter, because every time we learn a new graph, we're going to use the exact same rules to move them, to transform them. It's a huge lesson. So buckle up. So first one's all these graphs we should already know. That was just a typo. So constant function, right? Y equals, anytime put like y equals anything, just goes to that value and then draw a line straight across. Follow the tally mark. Identity function, it's y equals x. I should like to think of more of as a linear. Let's think about the linear function instead. Right, y equals mx plus b. And that's a transformation of the identity function, but that's what that is. Absolute value, we talked about the last lesson, right? Absolute value is just it makes this part positive, so it looks like a V. Quadratic might be a new one for you guys. We'll talk about more about this. We'll go in great detail next chapter, but quadratic function is it looks like a U. So first step, identify the type of function. Hey, this is, again, I like to say linear, but I guess identity. I prefer to say linear. And this is absolute value. Now, stuff's been happening to it, but it's an absolute value function. Like that's the parent graph. That's where we start off. This graph started off as this graph, and then we did stuff to it. We like shrunk it and we stretched it a little bit. This was an identity function that we moved up. So let's start off with transformations. So this is one we kind of talked about last time. Transformations is how do you move it up, down, left, right. And now, anytime you get a basic graph, I want you to know two things. With the inside, here's the inside part of the function. The inside part of the function affects the x values. It's a short way for me to saying it affects it horizontally. Right? X values move left and right. So when I say the inside, you can move something left and right. Because again, inside affects the x values. So that's on the inside to move it left and right like the x's. Just left and right. And in this case, if you remember what we did last time, you do the opposite. It's kind of like you're solving it. So it's x minus 4, you're actually going to solve it and you get x plus 4. You do the opposite of what it says. So for example, we did this last time. If I give you absolute value of x minus 3, this is on the inside, so you do the opposite. It's like a plus 3, which means you're going to move it right 3. So we have a graph, we move right 3, then we draw our absolute value function. So that's what the inside does. So anything on the inside moves it left and right, we call that a horizontal translation. Anything on the outside that affects the y value. If you look at the y values move up and down. So it's to move stuff up and down. Now it doesn't have the same parentheses, so on this side, on the outside, you just follow what it says. If it says move up, move up. If it says move down, move down. So for example, we did this a little bit last time. If we give you absolute value of x plus 4, that's on the outside, so we're going to move it up 4. So we'll get our basic graph, and then draw absolute value. So that's what those basic transformations do. And this is the key to all transformations. Just got to remember that inside is the x values, which means you move left and right, and you do the opposite. Outside is the y values, which means you move up and down, and you follow what it says. Inside opposite, outside follow. Inside opposite, outside follow. Okay, let's practice a couple. Describe the translation instruction and graph the function. Now, the first step is actually always identify what's on the inside and what's on the outside. Because if you do that, then we can follow inside x opposite, outside y follow. So look at these things. This one right here, that's the inside. Right, that's inside the function. Where if it was like this, that would be outside the function. On this one, that's outside the x squared, so it's outside. An inside version would be something like this. That would be an inside. Notice how it's inside the parentheses. So wherever there's kind of parentheses, if it's inside the parentheses, inside, outside, outside. So here it's on inside, and it's inside x opposite. So I'm going to treat it like a negative 3. And I'm going to go, x means left and right, so I'm going to go left 3. So 1, 2, 3, and then I'm going to draw an absolute value graph. And we're just doing a sketch here. It's not a perfect graph, just kind of a sketch of what's supposed to be going on. So it looks like that. If you have an x squared graph, an x squared graph looks like a u. And in this case on the outside, outside is y, follow. Remember, y's go up and down. So we're going to just use follow. So we're going to go down 4. Set a graph, 1, 2, 3, 4. Then you draw a parabola. Again, we're just doing kind of a sketch. What it should kind of look like. So it's inside effect. Inside x opposite, outside y follow. So that's how I move something up and down. And I always like to do is to add it. It doesn't have to be basic graphs. I can do this with anything. If I give you a graph like this, let's say f of x looks like this. Let me actually get points here. So look at this point right there is going to be -2 and 2. This is 1 and 4. And this is 1, 2, 3, 4, 5, and 4. So that's I'm just saying f of x is that. -2, 2, 1, 4, and 5, 4. If I say, hey, I want you to graph f of x -3. So one thing you can do is, you have this graph, so this is on the outside. Outside y follow. So that means we're going to move it up and down, we follow, so we're going to move it down 3. So one thing you can do is get every single point, move it down 3. So get that point, down 3. Get this point, down 3. Get that point, move it down 3. And that's your new graph. Another thing you can do though, is get the actual points, right? So this thing's saying, hey, on my y, move it down 3. So if you get your points here, which are -2 and 2, 1 and 4, 5 and 4. If you just subtract 3 from all the y values, you get the point -2, -1, 1, 1, and 5, 1. Look at the points I got. -2 and -1, 1, 1, 5, 1. So that way also works. That same idea, right? If I just give you a basic graph of points, you can either just do the same thing, move every single point down 3, or this actually math. Hey, I gotta subtract 3 from all my y values, subtract 3 from all the y values. You get the exact same answer. So we'll do a couple more of those later. Next is let's talk about reflections. So reflections are when you flip your graph. Now this is generally supposed to be the first step. So you're actually supposed to do reflections before you start moving stuff. So there's 2 types of reflections. Let's focus on the inside one first. So one that looks like this. So notice how it's on the inside. Inside's x. Opposite follow doesn't really matter here because we're just flipping it. So we're going to flip it across the x. So we're going to flip it like horizontally, right? Left and right. So I call this a horizontal flip. Because x is horizontal. So you're going to flip it left and right. Most books call this a y-axis flip. Because when you flip it left and right, you're flipping it across the y-axis. I think it's a little more confusing. I just like to say horizontal flip. So let's do a quick example. I'm just going to give you a basic graph. Let's say f of x looks like this. So that's my f of x graph. And then I'm going to say, let's graph f of -x. So you notice how it's on the inside. Inside's x. So we're going to move it a horizontal flip. Anytime you see a negative, it's a flip. So we're going to flip it horizontally. We're going to flip it like this way. So if you flip it horizontally, it's going to be like right here. And you can go like that. My best to match it. It's a little too high, but that's the idea. Right, you flip it across here. Horizontal flip. That's what the negative inside does. Flips it horizontally. The negative on the outside y. Remember, y is up and down. So I call this a vertical flip. We're going to flip it up and down. Most books call this an x-axis flip for the same idea. So you flip it up and down, you're flipping it across the x-axis. again, for me, that's a little confusing. I prefer vertical flip, so you flip it up and down. So for example, we'll do the same graph. So I have that graph right there. Let's draw it again. It's my f of x. And then I want to draw negative f of x. Alright, so it's on the outside. Y, it's a vert flip. So we're going to flip it up and down. Vertical flip. So it's going to look like this. Again, I was trying to match it. Not the best, but that's the idea. So you flip it up and down. So if you see a negative on the outside, you flip it up and down. You see a negative on the inside, you flip it left and right. So that's called a reflection. Let's do a couple quick examples. So with these, actually, I think it's better if you draw it first. So it looks like this. That's my, look at the basic function, right? They call it the paired function. It looks like that. It's an absolute value graph. There's a negative on the outside. So that's y, so that means it's a vertical flip. So we're going to flip it up and down. Something like this. Remember, we're just doing a sketch. So that's a negative absolute value of x. Flip it up and down. Now this graph, there's two ways to do it. So you're saying, is that the inside or outside? Honestly, it doesn't matter. With the basic x, that's either one. It's an inside and an outside. It doesn't, like, there's no real inside or outside for a basic x. For that right there. So basic graph looks like this. So now in this case, it's a rare case I counted either one. We'll say we'll flip it horizontally. Alright, so you flip it this way, then you get a graph that looks like that. Which would have been the same thing, flip it up and down, right? That goes down here, that goes up there. So that's what it looks like. Oof, that was bad. That's even worse. I'm gonna stop doing. I'm making it worse. I'm gonna stop. Anyway, I wouldn't even do it that way. Ha. The way I would do this, the way linear graphs, don't even worry about it. Just do a normal graph. We know how to graph that. Starts at 0, slope of 1/1. Negative 1/1, right? So do it like a normal graph. Like how we know how to do it. Don't overcomplicate it. I wish I could draw a straight line. Anyway, that's flips. So again, inside opposite, outside follow. Like before, I could do it with the basic graph. Let me give you a basic graph here. I'm gonna try to do kind of the same graph I did earlier. Might be a little off, but same idea. Let's say, I think this was like -2 and 2. This is like 1 and 4. We'll say 5 and 4. Right, so I'm gonna do the exact same idea. I'm gonna ask the graph negative f of x. So in this case, one way to do it is you go, okay, it's on the outside. So that's y. So it's a vertical flip. Again, y tells me we go up and down. So we're going to flip it up and down. That's all that y tells me. It's y is up and down, we're going to flip it up and down. So you flip it down. It's kind of like this. Right, you can flip all those down there. So it's going to look like this. So that's one way to do it. Other way to do it, like I said earlier, you can actually just do the math on it. What's going on here is this. You're multiplying your function by -1. So if I get all my points, another way to do this is just multiply all your y values by -1. So if I multiply my y by -1, I get -2, -2, 1, -4, and 5, -4. If I graph that, -2, -2, 1, -4, 5, -4, right? It works either way. That's the great thing about this, right? You could just do understanding the concept of, okay, I gotta flip it up and down, so flip it down. Or you can do the math of it and just go, okay, I'm multiplying my graph by -1. So you have to multiply, since it's on the outside, multiply the y values by -1. So you get your graph, multiply the y values by -1. Let's do the same thing for the inside function. Right? So if I was doing this the old-fashioned way, I go, okay, it's on the inside, x, so that means I move it left and right, right? Because again, x means left and right. So horizontal flip. So I'm gonna flip it like this way. So how does that work? It's a little tougher. So you're gonna flip it like over here. That goes right here, and and that goes over there. So look kind of like this. It's supposed to be straight. Again, not my best graph, but that's what it's supposed to kind of look like. Right, that's one way to do it. Another way of doing it is, well, on your x's, it's a little tough. This part's so messy. Right, inside opposite, so normally I say, oh, multiply by -1, but actually inside you do the opposite operation. We're going to divide by -1. Right, it's a little tricky, but you divide by -1. So let's go look back here. So ignore this. Instead of multiplying my y by -1, we're going to divide our x by -1. So get all the x values, divide them by -1. And I get 2, 2. 1 divided by -1 is -1, 4. And we're only doing the x values, so -5. 5 divided by -1 is -5, 4. If you look at my points, that's kind of 2, 2. That's what I was going for there. -1, 4, -1, 4, and -5, 4. Alright, so there's always two ways to do it. You can always just understand the concept and go, okay, I gotta flip it up and down, I gotta flip it left and right, or you can actually do the math. If it's on the outside, it affects the y values, so multiply your y values by -1. Oh, it's on the inside, it affects your x values, so divide your x values by -1. The divide part's a little funky. Remember, inside opposite. So instead of multiplying, we're going to do the opposite operation. We're going to divide. Okay, so we got how to reflect it, how to flip it. We got how to move it up and down. Last part of transformations is how to stretch and shrink it. So when there's a number on the outside, it's kind of like the slope. So that number is going to stretch or shrink something. Same thing when there's a number on the inside. Now that's the one we're going to focus less on in this class, but in general. When you multiply by a number, you're stretching or shrinking, you're making it bigger or smaller. So let's talk about the outside one first. Hopefully by now you can notice, if it's on the outside, it's going to affect the y values. So right, and we follow. Outside y follow. So basically we're going to multiply y values by a. Now the general idea is this. If a is bigger than 1, call that a stretch. It makes your numbers bigger. If a is less than 1, but bigger than 0, I don't really care about the sign. If I see like a -3, that means it's on flip. It doesn't do anything else to me. If it's a 3, it's a stretch. If it's a -3, it's a stretch with a flip. So we only care about positive values. So it's a shrink. And honestly, the best way to show you this is I'm going to use the website Desmos right here. So it's a nice free website. Start graphing. So let me show you, let's graph something. I'm going to go y equals, let's just show x squared. X squared. Let me zoom in a little bit. Maybe a little too much, but there we go. Y equals x squared. Then I'm going to do another graph. Show what happens when we put a big number on the outside. Y equals 3x squared. You see that one? It's stretched it up. So it's kind of like a slope. So at 1 you can go to 3. So at 1 goes all the way up to 3. Where normally it's 1, 1. Now it doesn't follow exactly. It does follow exactly when it's linear. Like an absolute value follows perfectly, but parabola is not actually a slope, but it's kind of like the slope. So 1, 1, and then 3x squared goes 1 to 3. So you can see it stretched it up. If I get really high, if I go to like 10, it's even more of a stretch, right? To me at 1 it's going all the way to 10. After that it doesn't really follow it, but that's the idea. Right, 1, 5, 2, right? You can see the bigger the number I get, the closer to the y-axis it gets. And when I go, if I put a negative in front of it, all it does is move it down, right? It doesn't do anything else besides flip it up. Now if I put a fraction, then it makes it wider, right? It shrinks it down, squishes it down. So I can put like a 10 down here, it makes it really wide. Now the slope thing doesn't follow as well, but it's more like at 1 it hits at 1/2. It's like that's where it hits. It's like that's where the 1 hits. If I do a 10 there, it's gonna hit at 1/10. So that's what an outside stretch shrink does. The bigger the number, the skinnier it gets because it goes up really fast. So if I put like a 5 there, it gets skinny. The smaller the number, the wider it gets. So that's a outside y shrink and stretch. On the inside x opposite. So now this is a little tougher because what we're going to do here is, so right in this one we multiply multiply y values by a. And this one, we're going to divide, right, inside opposite, we're going to divide x values by b. So in this case, it's the opposite. So if b is bigger than 1, it's actually a horizontal shrink. Because you're dividing by a big number. If you're dividing by like 5, you get smaller. By the way, I should put vertical stretch here and vertical shrink here. Very important. If b is less than 1, think about you have something and you divide it by like a fraction. What happens there is you multiply by reciprocal, you actually get bigger. When you divide by a fraction, small fraction, you get bigger. So it's a horizontal stretch. Again, best way to show you, I'm just going to go back to decimals. So in this case, let me put something in parentheses. So parentheses 3x. Right, now again, what do we say? Inside opposite, so it's gonna be we're gonna divide all our x's by 3. So at 1 divided by 3, it hits at like a third of that. Right here. I could count. Probably 2, but a little easier. Right, so at 1 it hits at 1/2. Right, so it's a horizontal shrink. If I put a small number there, it makes it a lot bigger, right? Makes it wide. You multiply your x by y, 5, so it stretches it out. You might notice that horizontal stretch is an awful lot like a vertical shrink. Well, kind of, yeah. They're the same thing. Like, let's say I put 3x squared right there, right? That's a horizontal shrink, right? It makes it horizontally smaller, right? It goes from here horizontally, makes it smaller. It's the same thing as a vertical stretch. Let's say I simplify that out, right? I just square everything. I get 9 equals 9x squared. Exact same graph, right? It's the same thing as a vertical stretch. So in this case, I have a vertical stretch, which makes it skinnier, or I could have horizontal shrink. Same thing. So they also call it dilation. Let's do some examples real quick. Now again, we're mostly just do a stretch. Now this one's easy. Again, with these is don't overthink it. Graph it like normal. There's that. My slope is 3/5. You go up 3 over 5, and you get your graph. Now with the next one, let's actually try. So first, let me put a grid on here. Okay, that's all right. Not my favorite thing in the world, but let's do it there. Okay. So now, right, look what's going on with this one. Didn't want that to be blue. Oh, let's go with it. So first, notice that's on the outside. So outside, y follow. So it means it's a vertical stretch. Vert stretch. Let me put some things on it, some markings we have, something to go with. Again, for most part, it's still just a sketch, but let me show you what a basic one looks like. Right, if we're doing a normal graph, it would be it's a parabola, so start here, cross that 1, 1. So it looks like this, crosses that 1, 1, it kind of jumps out from there. Now this one, again, the best way to think about it is kind of like slope. You can start that from the very beginning. So we're going to go right 1, up 3. Now it's not exactly slope, it doesn't follow it after this, but it's a good way to start off your graph. So 1, 3, and it goes like this. You can see there's a little bit of a stretcher. It's more of a vertical stretch, right? It's thinner than it normally is. So vertical stretch of factor 3. So that's how you do it. Now let's kind of put all stuff all together. So first we'll do a quick application problem, which just talks about it. The manager of a coffee shop is randomly checking coffee drinks prepared by employees to ensure the correct amount of coffee is in each cup. For each 12-ounce drink should contain half coffee and half steamed milk. The amount of coffee by which each drink varies can be represented by this equation there. Describe the transformations in the function. Right, so all I want to do is describe what it looks like, and then we're going to graph it real quick. Well, so the way we're going to do this is like this. This is on the inside. So inside opposite, inside x opposite. So again, inside x tells me it's moved left and right, and opposite means the opposite of that. So it's a minus 12, we're going to treat it like a plus 12. So we're going to move it right 12. So you can say shift right 12 or just move it right 12 units. So that's the first thing. Then the 1/2 here, notice that's on the outside. So this is on the outside y follow. So again, y tells me it moves up and down. And this is we're multiplying, so it's a stretch. So we're going to stretch it. Actually, in this case, it's less than 1, so we're going to shrink. So it's a vertical shrink. Spelled correctly. Factor 1/2 of 1/2. So we're going to shrink it by 1/2, and we're going to move it right 12 units. Now, if I want to graph it, we'll do a very basic, quick one. I used to move it right 12. Let's say here's 12. And then this one you can actually do like slope. We'll go up 1 over 2. Up 1 over 2. So look kind of like this. There we go. Now let's go backwards. So in this, we want to write equation for each one. So first key is understand what the parent function is. This is a parabola. So we're going to write y equals x squared. That's what it basically looks like. Now what's going on is it moving up, down, left, or right. It looks like it's moving up 1. Remember, if you move up and down, it goes on the outside. So out to my equation, I'm gonna write in like this. On the outside, I put +1. Outside equation. Over here, this is an absolute value graph, so it's something like this. But in this case, we're moving it left 3. 1, 2, 3. Yeah, -3. Left 3. Now, when we move left and right, that goes on the inside. Inside x opposite. So we're going to put an inside. Now, also, we have to make the opposite. So instead of a -3, we have to put +3 here. And that's what it looks like. That's the next one. This is one where people mess up the most, is when it's a parabola moving left and right. So this one, probably the best thing to do is find the vertex right here. So it looks like -4 and -6. So that lets me know it moved left 4, sorry, and we moved down 6. Right, our base graph looks like this. Now, on the inside, I gotta move it inside x opposite. This is where most people mess up. A lot of people give me this. I see this all the time for inside. That is wrong. The square has to be on the outside right there. So it looks like a +4 to me. That's on the outside. So the way you want to write this is y equals x inside opposite +4, close it, and then put the square. And then out here we went down 4, right? Outside 6, outside y follow. So on the outside we're going to put -6, so we fall on the outside. That's what it should look like.